Mole-mole relationships. So we saw how we can interpret these balanced chemical equations in terms of moles. And so we can look at this equation and get mole ratios. So how many moles of oxygen are going to react with 2.25 moles of nitrogen? Well, we know that 1 mole of nitrogen will react with 1 mole of oxygen. So we can use that. That's a mole ratio. We can use that as a unit factor. For every 1 mole of oxygen, we need 1 mole of nitrogen. So if we have 2.25, okay, I'm just going to start over because I didn't leave enough space. 2.25 moles of nitrogen. We want to figure out how many moles of oxygen, and we can divide by moles of nitrogen. This is a ratio of moles, a mole ratio, and the equation tells us what it is. There's no subscripts here, but we understand those to be ones. 1 mole of this to 1 mole of that. 1 mole of nitrogen for every 1 mole of oxygen. So these units cancel out, and we end up with 2.25 moles of oxygen. And you may think, well, duh, I could look at that and see that the number of moles have to be equal, right? So if you've got 2.25 to start with, you need 2.25 of the other. Well, that's great when it's 1 to 1. But we need to learn how to create mole ratios from these balanced chemical equations. So that if we are given, some more difficult equation, we can figure it out. So this one's a little more complicated. Iron is produced from iron ore in a blast furnace by passing carbon monoxide gas through the molten iron 3 oxide, and there's the balanced chemical equation. How many moles of carbon monoxide will react with 2.5 moles of the iron 3 oxide? We're going to approach this using unit analysis. So we are given number of moles of Fe2O3, and they're asking for moles of carbon monoxide. So I'm just going to write this down, 2.50 moles of Fe2O3. I want moles of carbon monoxide, CO, and so I need to divide by moles of Fe2O3 because I want these units to cancel out. You with me? The mole ratio comes from the coefficients in the balanced chemical equation. What number is in front of Fe2O3? A 1. So then here in my ratio, I'm going to write the same number in front of Fe2O3. What number is in front of CO? It's a 3, so I'm going to put a 3 here. Is that easy? Yeah. Some things in chemistry are easy. So then we've got 2.5 times 3, 7.5. We're going to need 7.50 moles of carbon monoxide to react with that amount of the iron ore. Any questions? How many moles of iron are produced from that 2.50 moles? Using this equation, we can establish a relationship between any 2 of the substances. 2 reactants, like we just did, a reactant and a product, or 2 products, any combination. So the balanced chemical equation is a great source of unit factors for these calculations. So we're starting with the same number of moles of Fe2O3. But this time we want to know moles of iron. So we'll multiply by moles of Fe. We'll divide by moles of Fe2O3. We want these to cancel out. It's all about the units. Then we look in the equation, and there's a 2 in front of iron, so I'll put a 2 in front of iron. There is an implied 1 in front of Fe2O3, so I'm going to write 1 here. And I do the math, and I get 5.00 moles of iron. The coefficients in the balanced chemical equation are exact numbers because this goes down to the particulate level. One molecule or one formula unit of this will react with exactly 3 molecules of CO to produce exactly 2 atoms and 3 molecules of CO2. When we multiply by mole, we're just increasing the magnitude of this, but the ratios are still the same. So these mole ratios are exact numbers, and so we're just going with how many sig figs did we start with? Same number in our answer. Any questions?